We've come across the concept of peak power already being the maximum amount of power demand within a system. And one of the reasons that peak power is so crucial in a power system is that it determines the amount of power capacity, the amount of power stations and other infrastructure you have to have, because the key goal of any system operator or government is to keep the lights on. Now, keeping the lights on isn't just about having just enough power generating capacity to meet peak demand. You also need to have some security. You need to have some leeway, a margin above that capacity. So that's what I'm briefly going to describe here, is this idea of capacity margin. This chart's one we've seen before, and it's just reiterating this idea about baseload power being a minimum level of demand and peak power being the maximum level of demand that we see within a system. Obviously, when you're designing a system to be reliable and to keep the lights on, it's not just the level of peak demand on one particular day that's going to matter. You also need to worry about the maximum level of peak demand. After all, your system's got to be built so that it's capable of meeting the absolute maximum peak demand you're going to encounter at any point in time. So we've also seen this chart before, which was UK power demand over an entire year, from the 1st of January on the left of the chart to the 31st of December on the right. The single largest peak in demand in the UK during 2015 was on the 19th of January, and it was just under 54,000 megawatts. I've also indicated here the installed capacity of what the UK government describe as major power producers. By that they mean large utility scale connected power plants. So it's missing off some smaller producers and some other distributed resources, but it's capturing most of the major power plants that we have. The first thing you'll notice is obviously that's a much larger number. It's closer to 77,000 megawatts, much larger than the single maximum peak we had during that entire year. So that in itself is telling us that there is much more power capacity in existence than is ever needed to meet the maximum load in this particular system. Bear in mind that in summer, the middle of that chart, the maximum power demand never gets above 40,000 megawatts. So you've got almost twice as much installed capacity of power plants, of power producers, than you ever need power demand in the summer months. However, simply the difference between our total installed capacity of power plants and the maximum load, the peak demand that we get during the year, doesn't reflect this idea of a capacity margin. It doesn't actually reflect the safety margin that we have to keep the lights on, which is what we call capacity margin. Instead, to understand capacity margin, it's not the total installed capacity that matters, it's the capacity available at the time of our peak demand that is important, because some of that installed capacity simply won't be available. It may be down for unscheduled maintenance, for example. And the expectation of that available capacity is something that the system operator will need to know at the expected time of peak demand. So let's say, for example, that at the time of this peak demand of just under 54,000 megawatts in the UK, of the total capacity of power plants in the system, the expectation was that 65,000 megawatts would actually be available to generate if required. The difference then between the available capacity and the peak demand is more like 11,000 megawatts. 11,000 megawatts is 21% of the peak demand. And that's how you would define the capacity margin. So the capacity margin is not the difference between the total installed capacity of power producers and the peak demand. It's the difference between the available capacity at the time of that peak demand and the level of peak demand. And if the numbers we've used here were representative, then that would be a very healthy capacity margin. It should also be clear that that capacity margin is going to be smallest at the time of peak demand. In the summer in the UK, the capacity margin is not likely to be a problem. There's so much capacity in the system and relatively little demand that resilience and security of the system are really not a problem in summer months. And as we can see, those levels of real peak demand are not very often. There are a few spikes in those winter months, but really the times at which we're worried about whether we have enough generating capacity to meet demand are very limited. Of course, to turn this the other way round, what a system operator is looking to do is not just to know what the capacity margin is at times of peak demand, but they want to ensure that the margin stays above a reasonable level. 21% would be very high, but potentially something down at kind of 5 or 6% might be regarded as rather too low, because if your expectation on available capacity wasn't met at that peak time, for example another power plant went offline unexpectedly, then you are starting to be in danger of not being able to meet your peak demand. So knowing your peak demand and then adding a level of capacity margin on top, and in turn based on things like the ages and reliability of the power plants in your system, is going to determine the capacity you need in your system. So peak power demand determines how much capacity we require over and above our peak capacity, and bearing in mind some assumptions on how available that capacity is going to be at particular points in time. But bear in mind that peak power demand doesn't last very long. So in our system, when we've made sure that we've got this capacity available to keep the lights on at those peak times, for most of the time, there's a lot of infrastructure that's sitting around not being used much, because most of the time the system isn't at peak demand. And that's a concept we'll explore in a bit more detail in the next lesson. Okay, thank you.